Good day, everyone. In the previous video, we have provided a brief review about what discrete math is, about the kind of problems discrete math can do, and why we need to learn discrete math. And that is the ability to learn to solve problems and to construct mathematical arguments. And in the previous video, we have also mentioned how logic gives precise meaning to mathematical arguments. So for today, our main topic is about propositions. So propositions are the building blocks of logic. But what are propositions? Okay, so let's proceed. So when we say a proposition or a statement, we refer to something that is declarative. So that is a sentence that declares a fact. And from the word na fact, you can either verify it to be whether it is true or false. And the fact can never be both na true or false. So it has only one true truth value. Okay, so we have a statement, and is this a statement a fact? So if it is, then it is yes, it is true, it is a fact. If it is not, then it is false. Okay, so we have here a following example. So we have first 1 plus 1 equals 2, second 1 plus 1 equals 3, and 3, he is a university student. So which of these three are considered as propositions or statements? Yes, it is 1 and 2. So 1 and 2 are both declarative statements. So 1 plus 1 equals 2 is true, okay? And it can never be false. And the other example, 1 plus 1 equals 3, is also a statement because it has a truth value which is false. So you can easily verify that 3 can never be 1 plus 1, okay? But why is it that he is a university student is not a statement or a proposition? Okay, so the third statement is neither true or false. The truth or the falsity depends on the reference for the pronoun he. So he refers to no one in particular. So we cannot verify whether it is true or false unless we give a certain value to he. So when I say that one of you is a university student, so you are in this class because you are enrolled in a university, and that is a fact, and that is true, okay? And because it has a truth value, so it is considered as a statement or a proposition. Okay, so let us have more examples. So we have the following statements, and we will determine which of these are propositions. So let's start with the first one. So 1 plus 1 is equal to 2. So it is similar to the previous example, except that it was expressed in an English statement. So this one is just expressed in a mathematical way. So we know that this is a declarative sentence, and we can verify that it is true. Okay, so it is a proposition. The other hand, 2 plus 2 is equal to 3. It is false, and it is also a declarative sentence. Okay, so meaning it is also a proposition. So what time is it? It is not a proposition. Why? It is not a declarative sentence. It is a question rather. So it doesn't have a value of true or false. So read this carefully. It is also not a declarative sentence. It is a command, okay? And a command can either be true or false. And lastly, x plus 1 equals 2 is also not a proposition or a statement because it can neither be true or false. Because x doesn't have a value, we don't know the value of x, so we cannot verify whether this statement is true. But you can turn it into a proposition if we assign a value to the variable x. So for instance, when we replace the value of x with 0, so 0 plus 1 is equal to 2, that will be false, meaning it can we can now verify whether it is true or false, and therefore it is a proposition. Okay, every statement or proposition has a truth value, as you have seen earlier, namely true, which is normally or typically denoted by T, or false, which is typically denoted by capital letter F. And we are also using propositional variables or statement variables, or that is letters or variables that can represent propositions. Okay, so these are the conventional letters used for propositional variables: P, Q, R, and S. Okay, so the area of the logic that deals with propositions is called as the propositional logic or propositional calculus, and that will be the main topic that will be used all throughout this that we will be discussing all throughout this session. Okay, so propositional calculus or logic was developed systematically by the Greek philosopher Aristotle more than 2,300 years ago. Okay, now we will proceed to the next topic in the next video.